Welcome. This is the fifth in a series of videos demonstrating the use of two software packages, pfodDesigner and pfodApp. So today we're going to jump right into pfodApp. And what's going to be displayed here is page one of a two-page program that I previously put together. And in Designer, when you used Designer previously or had a look at it, there's 9 menu items available. And on this page one here, I've got 7 of the 9 listed, and on page 2 there'll be another one, on-off display, and the very last one, plots, is not going to be covered at all in this video. That's a separate subject all in itself. So you can see up here that I've got a label, on-off setting, pulse width modulation output, button, data display, submenu, and drawing. You'll also notice that this is underlined, all of these. They're in a different color of font, and they're in a different size of font. And I'm going to show you right now how that's done by the use of what the developer refers to as formatting tags. So we'll go ahead and have a look at the program on the laptop, and we're going to look at the difference between these two here, right here. The one that's got button in front of it, because these are both buttons. But this one's got the italic button in front of it in fuchsia, the color, and underlined. And this one has nothing. Now I'd also like to point out at this time that the formatting tags you use and the wording here, like on-off setting, pulse width modulation, button, etc., these are added after you've generated your code in Designer and then transferred it to your laptop. And in my case, I'm using the Arduino IDE editor, so we'll go ahead and we'll go over to the laptop right now and have a look. So now we're at the laptop. And these 4 lines of code here represent the 2 buttons that we previously discussed. Now the first thing I'd like to point out is there's a great deal of information available on the pfodDesigner software as well as the pfodApp software. And it's available in terms of pfod specification PDF file. It's available from the developer's website, Forward Computing and Control Proprietary Limited. And if you download that, you'll see on pages 13 through 17 it discusses formatting tags. And on page 16 it also gives a list of the hex values for 256 color palette. Now as we can see here, this is the information that's generated for one button. There's 2 lines of code. This is automatically generated in Designer. So if you were to go into Designer and generate just 2 buttons, for a menu, you would get 4 lines of code in your main menu. And if you're starting a new menu, which is what I would recommend, you're going to have, this is going to be labeled as A, this will be labeled as B, because the pfodDesigner software just takes the letters and automatically assigns them. And you can change them, of course, but I just happen to have J and K assigned with when I was building this. But with the first button, you can see here that it's got a background, navy. This stands for bold, that B. This is -2, that's the programmed font. And this is yellow, this is the the color for the font. Now what I've done here is, this is where these formatting tags come into play. I've added an extra word here called, button, with the semicolon, and I've stuck that in front of the word ink. And this is where you put your formatting in, right in front of that particular word if you want to change that word. So what I've got here is -1, and that refers to not the program font size, but it refers to the change in font size from -2, which is what it'll revert back to once we do the escape sequence. This F is for fuchsia, the color, I is for italic, and U is for underline. Now this is the escape sequence you use when you escape these particular formats here. And you only have to use either the first formatting tag or the last formatting tag according to the pfod specification. But I just go ahead and I just use the first formatting tag, which is -1 here, so that this is the escape sequence. And once you implement your escape sequence, you go back to this format here, and that's about it. You can see on the next button here, I've done nothing in terms of, this is the text on that button. I've made no changes to that, so it's just as it appears But I also wanted to point out that with these letters like Y and you got R for red and whatnot, you've got 16 colors available if you just want to use letters. But if you want to use, the 256 colors available in the palette, you can refer to page 16 and you can enter that. Like this here is actually, the FFFF00 is yellow. Refers to the color yellow, so you can have yellow in there as as the letter Y, or you can have yellow in there as under the hex value. And of course, if you use the hex values, you've got a wide range of colors to choose from. And that's about it for the code. We'll go ahead and we'll go back to the tablet now. So now we're back at the tablet, and we'll take a little closer look at the menu items I've got here. On label, you can have 125 characters per label. Theoretical voltage is calculated with pulse width modulation pin 11 setting. Lap seconds computed by code. Frequency is pin 3 interrupts. A0 is 5 readings average, which I'll explain a little bit more in a few seconds here. On-off setting, all that'll do is just turn the timer on and off here to start the program running. Pulse width modulation, well, that's your duty cycle output on pin 11. And pin 11 I've also got going into pin 3, which you'll see in the drawing. Interrupts going into pin 3 to read the frequency coming off of pin 11. These two buttons, these are for fine-tuning your pulse width modulation, increase and decrease. Data display, all three of these are data displays. This one is your seconds, of course, and this one is your interrupt frequency. And this will be your filtered voltage out, your 5 readings averaged off of A0. So going down to the drawing, I'm using an Arduino Mega microcontroller, and I'm using the BLE UART friend from Adafruit. And these items down here, these are what's referred to as a filter. And it's just basically a filter for averaging out your analog output from a pulse width modulation output. So you get a relatively steady. If you've got a good filter, you can have a relatively steady analog output voltage going into pin A0. The results aren't too bad, but overall I still had to average 5 readings, and I'm on a 5-second sample rate, so 5 readings on a 5-second sample rate. Yeah, I'm pretty pleased with the results. They work fairly well. So we'll go ahead now and we'll turn sampling on. And that'll start the timer here. We'll see our seconds start to elapse. Again, like I said, a 5-second sample rate. Right now I've got no output because I've got no pulse width modulation, so I've got no analog output, and I've got no frequency going into pin 3. But as soon as I move the pulse width modulation up to, say, well, whatever, I'll pick 3.14 volts, just as an example. The interrupt frequency in pin 3 jumps to 490 hertz, which is your, that's your frequency, your pulse width modulation frequency out of pin 11. If you look at the Arduino Mega specs. And the filter output, 3.14, yeah, 3.14. Yeah, the results are pretty good. We'll just move it a bit more. Theoretical, we're asking for 4.47. We're getting, 4.47, 4.48. So as you can see, you can make your your menu items that you pulled up out of Designer, your buttons and whatnot, data displays. As you can see, you can make them a little bit flashier with these formatting tags, eh? And yeah, it actually looks pretty good. So what we'll do now is we'll just go ahead and we'll jump into well, first of all, I'll take the voltage down to 0 here. I'm just using a mouse this time. I guess I could use my stylus as well. I'll take the voltage down to 0. I'll turn sampling off, and our seconds should go to 0, yeah. Now, submenu, drawing with data displays. we'll pull up page 2. Now what I've got here on page 2 is basically the same controls more or less as page 1. With the exception of the drawing here, the drawing incorporates data displays as well. And also you'll see in future videos on the drawings, you can also have control buttons which you can set up in your drawing. And we'll get into that a little bit in a little bit later videos. But for this one here, if I turn sampling on, it's a little bit more of the drawing there, a little bit more to process the code, but eventually our elapsed seconds will start to tick over. Now when we hit 10 there, just like now, this on-off display is flashing. And you've got a bell which is also going off in the tablet. And right now I've just got it set on a timer, so it's going to go ahead and turn off right now. But it's kind of handy if you want to, perhaps you want to catch an event happening and you don't want to miss it, and you're going to make a cup of coffee or whatever. You can have, an audible alarm on your tablet. Okay, let's go ahead and we'll turn pulse width modulation on. I'm going to go ahead and ask for 50%. The previous page I was asking for voltage out. This one I'm asking for percentage, but we're 5 volts, so we're asking for 2.50 volts theoretical. Now what this graph here is showing is your duty cycle coming out of pulse width modulation pin 11. And well, that's on your x-axis. Here on your y-axis you're showing your V out filtered. So in theory, I mean, your V out filtered should be exactly the same as your duty cycle, eh? If your filter is working, as well as you'd like it to be. The hertz, 490 hertz. Elapsed seconds, we're now at 95 seconds. Theoretical, asking for 2.51 on the theoretical. V out filter 2.51. Yeah, the results are pretty good there. So I'll just go ahead and I'll just move this output around a little bit. And as you can see, the theoretical is now 4.14, filtered is 4.13. Here's an interesting interesting fact that I observed when I first did this, but I mean it makes sense, of course. When you go up to 100% duty cycle, well, you no longer got a frequency coming out of pin 11. It's just you're asking for 100%, so it's just straight voltage on, 5 volts, eh? So you can see your frequency into pin 3 is now 0. So go ahead and we'll take this down a bit. And again, it'll take a couple readings to catch up. But yeah, that's about it. But as you can see, with the use of buttons and the use of formatting tags and drawings, you can build yourself, well, a very functional and highly attractive interface. And we'll also see in future videos, when we get into drawings a bit more, interactive controls. You can set up touch zones in your drawing, and when you click on a certain area, you can have certain events take place, and that's a whole new area of exploration there. So I'll take the voltage down to, or the pulse width modulation, I'll take it down to 0. Let it settle out here, and then I'll turn the sampling off. Our frequency hertz will go to 0, and our elapsed seconds will go to 0. So that's it for this video. We'll see you at the next one. Thanks.